In this screencast, we're going to take a look at the third type of bonding, which is metallic bonding. So we've looked at covalent bonding, which is where electrons are shared. We've looked at ionic bonding, which is where one atom gives up electrons and the other atom gains them. And now we're going to take a look at metallic bonding. So in a metal, you have vacant orbitals in the atom's outer energy levels. And those electrons from the outer energy levels are free to roam throughout the entire metal. And so let's say we have aluminum and we have iron. The electrons that are normally going around iron are now able to also roam freely around the aluminum. So we end up with this like figure 8 where the electrons are free to move around both atoms. Okay, and when they do that, we call this a sea of electrons. That's what it's called, sea of electrons. So these electrons form this sea of electrons around the metal cations. Because the electrons have broken off, what's left for the metal is a positively charged ion or a cation. So these metal cations are packed together in a crystal lattice, and the electrons are free to roam around. So this makes metallic bonds very good conductors of electricity and heat. And this bonding that results between the metal atoms and the surrounding electrons is what forms the metallic bond. So it's not quite as strong as an ionic bond, but it is still a pretty strong attraction between these metal cations to form the metallic bond. The unique characteristics of metallic bonding is what gives metals their characteristic properties. So electrical conductivity, which is the ability to conduct an electric current. The reason that this is so easy to happen because the electrons are free to move around. An electric current is just when electrons travel from one point to another. So since the electrons are free to travel, they can travel across the bond, and that creates the electrical current, the conductivity. The same thing with thermal or heat conductivity. Metallic elements are also malleable, which means that they can be hammered flat, and they're ductile, which means that they can be drawn into wires, and they also have a shiny appearance. So just make sure that you have these two definitions copied down into your notes. Malleability, again, is the ability of a substance to be hammered or beaten into thin sheets. So think of like a copper bowl or something like that. That's because copper is malleable. Ductility is the ability of a substance to be drawn, pulled, or extruded through a small opening to produce a wire. Again, think about like wires in your home or in electronics. We have a metal that's able to be drawn into this thin wire, and that's because it is ductile. Make sure you copy all these notes into your notebook, and if you have any questions, please make sure you ask Mrs. Benke in class.